In question 6 we're told about this guy John. He's been given two sunflower plants. One of them starts out 16 centimeters high, the other starts out 24 centimeters high, and he measures the height of the plants at the same time every day for a week. The shorter one grows 4 centimeters each day, and the taller one grows 3.5 centimeters each day, at least for that first week. So the first thing that we're asked to do is to draw a table showing the heights of these two plants each day for that first week, starting on the day that John got them. So what do we need to have in this table? Well, we're going to need to have the day number, so starting at 1 first of all. We need the height of each plant, so I'm going to give each of those their own row. I'm going to call them plant A and plant B. So the height of plant A and the height of plant B. And we're asked to do it for the first week, so days 1 through 7 essentially. So put in 1, 2, 3, 4, 5, 6, and 7. And present it nicely. Just for the sake of clarity, I'm noting that the heights are going to be measured in centimeters. So plant A, we'll say, is the one that starts out shorter, so that starts out as 16 centimeters high. It grows by 4 centimeters each day, so the second day it'll be 20 centimeters high, then 24, 28, 32, 36, and 40. Plant B starts out as 24 centimeters high, grows by 3.5 centimeters each day, so it's going to go 27.5, 31, 34.5, 38, 41.5, and 45. Part B asks us to write down two formulas, one for each plant, to represent the plant's height on any given day, and we have to make sure that we state the meaning of any letters used in the formulas. So hopefully you'll notice that the heights of these plants, because they're going up by the same amount each day, at least for each individual plant, the heights follow an arithmetic sequence. So we should know that the terms of an arithmetic sequence are given by this formula. Tn is equal to a plus n minus 1 times d, a being the first term in the sequence, d being the common difference, and n being the term that you're looking at. So let's say we're looking at plant A first of all. I'm going to say the height of plant A is going to be an. A being the first term is 16 for plant A, plus n minus 1 times the difference, that is, what's it changing by each time, in this case 4. So when we try and simplify that, we're going to get 12 plus 4n. If I do the same for plant B, I'm going to say the height of plant B is given by bn. The first term in that is 24. We add on n minus 1. Because this is a general formula, we got to keep the n minus 1 in there. And the common difference, that is, the height it's changing by each day, is 3.5 centimeters. And we can simplify that down a little bit to 20.5 plus 3.5n. And I suppose we should just clarify what we mean by each of these. So an equals height of plant A. Bn is height of plant B. And n is the day number, we'll call it. Part C essentially asks us to draw graphs to represent the height of those two plants over the first 4 weeks. The question is a little bit ambiguous in what it means, but essentially it says on one coordinate plane represent the two formulas that we just generated. Now, before you even start going and drawing graphs, make sure you take a bit of time and think about how big does your graph need to be, because the marks aren't just going for you representing the formula, it's also for the quality of the graph, and part of that is getting the scale right. So we're looking at the first 4 weeks. So what's that going to be? So let's say our x-axis is going to be the day number. That's going to essentially be our domain. If we're looking at 4 weeks, then that's 28 days. So we need to start at day 1 and we need to go up to day 28. What about the height of the graph? The range? It's a little bit tougher in this case because we don't really have all the information yet. But what's the lowest value? I mean, think about the height of these plants. They're going to start off at their lowest values, and at the end of 28 days, because we're adding the same amount each time, and they're getting bigger each day, then the last value should be the biggest y coordinate that we're going to need. So between the two lowest values, the 16 and 24, which is the lowest one of those, well, it's the 16, so our lowest value in the range should be 16. What about the highest value? Well, what's the maximum height that either of these plants are going to reach within 4 weeks? Well, let's just take a quick second to actually calculate that. So A28, that is the height of plant A after 28 days. It's 12 plus 4 times 28, and that's going to be 124. The height of plant B after 28 days is given by 20.5 plus 3.5 times 28, based on our formula from the last question. And the result of that is 118.5 centimeters. So this is the tallest that either of the plants are going to reach within 28 days. So we take the biggest one of those, and that is the maximum height that our graph needs to be. So before you even start drawing a graph, one thing you might be inclined to do is just, as soon as you see it's a graph question, just draw in your coordinate plane like that. But if you look at the domain and the range, the kind of points that you're going to need, they're all going to be in this portion of the graph. So if you start with your coordinate plane, you're wasting this space, you're wasting this space, you're wasting this space. And that's going to diminish the quality of your graph, and you could lose marks there. So this is along the lines of the graph that you're aiming for. You can see that my x-axis is going over 28 days or so, so this is number of days. And my y-axis is going just a little over 124. The height I would need is 124. I'm going a little above that just because I'm going up in tens. So this is height. And that's in centimeters. So let's say I'm going to graph the height of plant A in blue. Now, you should be able to recognize that the formulas that you generated are lines. So to draw a line, all you need is 2 points on that line. Now, in the very first part of this question, if I may go up to this table, we actually have 7 points for each line already. You don't need to generate any more, although we did generate the last point in the graphs as well. So you can just pick whatever ones you want. It's no harm to maybe use 3 just to be sure that you're graphing them right, because if they don't end up on the same line, then something's definitely wrong. So I'm going to scroll back down. Now I know the height of the first plant on day 1 is 16. So 16 is about there, and that's day 1. And on day 28, it ends up being 124. So that's going to be about there, I would say. It doesn't have to be incredible, but just approximately what you're looking for. Secondly, plant B was 24 centimeters on the first day. So that's about there. And ended up being 118.5 centimeters, so that's slightly lower than 120, somewhere around there. So because these are lines, you join them up. Now notice that I'm not going beyond the first day to the left, and I'm not going beyond the 28th day to the right. Because you were specifically told to draw the graphs to represent the heights over the first 4 weeks, then that means you're supposed to limit it between the first day and the 28th day. In the next question, you're asked, from your diagram, write down the point of intersection of the two graphs. So we go back up to our graph, find the point of intersection. Looks like it's maybe about there. Make sure you mark this very clearly on your diagram as well. So from there, make sure you draw lines straight down, and you draw a line straight across as well. You need to show the examiner how you're actually getting the point of intersection, the coordinates of that point, and you do that by comparing the point to each of the axes, and then you read the point off from there. So it looks like it's about 17.3, and the height looks to be smack dab on the 80. So that looks to be pretty much the point of intersection. The second part of that question asks us to sort of elaborate on what that point means. So we had 17.380 was the coordinate of the point of intersection. So we have to explain what that means. Well, what does the x-coordinate mean? So the x-coordinate means it represents the number of days that have passed since the first measurement was made. So I suppose it's the day on which the plants are the same height. What does the y-coordinate mean? Well, again, go back to what you're actually representing on that graph. The y-coordinate is the height of the plants on this day. The next part asks us to check your answer to part DI, so check that the point of intersection is correct using the formulae from part B. So let me remind you of those. We had AN was 12 plus 4 times N, and BN is 20.5 plus 3.5 times N. So to use these formula to verify that our answer to the last question was correct. So how do we do this? Well, these are two equations representing height and representing the number of days that have passed. We can solve them simultaneously by saying when they intersect, the height should be the same. So we say that AN equals BN as far as we know from the point of intersection. So 12 plus 4N is 20.5 plus 3.5 N, so just replacing AN with the formula that represents that, and likewise for BN. So if we mess around with that, we get 0.5 N is equal to 8.5. So if we get N, then that turns out to be 17. And we should just verify what the height of that is going to be on that day. So let's just take AN for example. That's going to be 12 plus 4 by 17, which is going to be 12 plus 68, which is 80 centimeters. So the coordinate that we're getting from this is not quite what we had the last time, so it's 17, 80. So maybe the graph wasn't perfect, it was very slightly out. It looks like the y-coordinate ended up being the same, but the x-coordinate was very slightly out. And the next part kind of plays on that. At least in this case, you may end up with the exact same point in your own diagrams. But it says the point of intersection can be found by either reading the graph or by using algebra. So essentially either the method used in part D or the method used in part E. So state one advantage of finding it using algebra. Well, it's kind of illustrated here in the example that I did, where if we use the graph, it looked like it was 17.3, so it was a little bit after day 17. The height was 80, but using algebra we got it to be exactly 17 days in and exactly 80 centimeters high, so algebra gives us accuracy essentially. So using the graphs does depend on how well your graph has actually been drawn, and it's not necessarily a fault of the way you're drawing it. It's sort of a fault of graphing it in general, especially with the graph that we had, because the lines were they have very similar slopes. It was very difficult to pinpoint exactly where the point of intersection was. And the very last part of this question says, John's model for the growth of the plants might not be correct. State one limitation of the model that might affect the point of intersection and its interpretation. Well, let's remind ourselves what the model is. Essentially, he says that the plants have a certain starting height. Then he measured their heights every day for a week, and he found it was the same every day for that week. They actually give you a little bit of a hint in this in part C, where it says John assumes that the plants will continue to grow at the same rates. That's exactly what one limitation would be, is he's making an assumption that the measurements he makes over 1 week, so measurements made during the first week, they won't necessarily apply for the entire 4 weeks. He's trying to extend his model. He's taken measurements from this first week and he's trying to apply them over the next 3 weeks as well, which isn't necessarily going to be the case. I mean, things will come in like maybe the sunflowers have a maximum height, or as they get taller they don't grow as quickly, or maybe they grow even faster as they get taller. Maybe it depends on the room. There's more lighting lower down or higher up or something like that. He's only making his measurements at one time, so we're kind of assuming that it's a line that's going up, but maybe they probably only grow during the day really when they're absorbing sunlight, and they probably won't grow so much overnight. So maybe it's not a straight line, but it kind of curves up each day. So there's a couple of different limitations of the model that you can use, and any of those should get you the marks.